Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, working at MLR Institute of Technology, Hyderabad. And in this lecture, we'll be discussing midpoint type cycloconverters, step up and step down type, as well as we'll also discuss bridge type cycloconverters. And here, in this lecture, we'll be discussing step up cycloconverters, that too midpoint type step up cycloconverters. And if you see here, output frequency is equal to 4 times of that of the supply frequency. Output frequency is 4 times of that of the supply frequency. That means for one cycle of input voltage, we are getting 4 cycles of output voltage. This is one cycle, this is one cycle, this is one cycle, and this is one cycle. That is, output frequency is equal to 4 times of that of the supply frequency. That means output frequency is greater when compared to that of the supply frequency. So what we call it as step-up cycloconverter. And now let us consider during the positive half cycle. This is during the positive half cycle, and during which the polarities will be positive, negative, positive, negative. And see here, as in order to get it 4 cycles of output for 1 cycle of input, in that case, firstly, I need to control positive half cycle of the output voltage, and for that I need to trigger. In order to obtain positive half cycle of the output voltage, in that case I need to provide the triggering pulse for the thyristor 1 such that it conducts current from A to B. See, if you provide the triggering pulse for the thyristor 1, it conducts current from A to B through the load, such that the positive half cycle of the output voltage will be controlled. And this is T1 is which is conducting during the positive half cycle of the input voltage. And now we need to provide the forced commutation. That is, firstly we need to commutate the thyristor 1 at this instant called T1 such that we can obtain the negative half cycle of the output voltage. So in order to obtain negative half cycle of the output voltage, we need to provide the triggering pulse for the thyristor 4. See, this is during the positive half cycle of the input voltage. Polarities are positive, negative. See, if I can provide the triggering pulse for the thyristor 4 such that it starts conducting current through the load from B to A, such that it controls the output voltage of the load, negative half cycle of the output voltage through the load. So that is the reason. If you observe, the current flow through the load is reversed to that of the first case when thyristor 1 has conducted. That is how your negative half cycle of the output voltage is getting controlled. And thereby, for a single cycle, I've got 1 half cycle of the output voltage. And now at this instant called T2, again during the positive half cycle, now since I need to control the positive half cycle of the output voltage, I need to provide the triggering pulse for the thyristor 1 such that it conducts current flow through the load from A to B, so that I'll get positive half cycle of the output voltage control. And now at this instant I need to forcibly commutate T2 such that I need to obtain negative half cycle of the output voltage to be controlled. Only then I can obtain 2 cycles of output for a single half cycle of the input voltage. So for that reason, at this instant called T3, now I need to provide the triggering pulse for the thyristor 4 such that this thyristor 4 now it starts conducting current through the load in the reverse direction to that of the first case. That is how now I am obtaining negative half cycle of the output voltage control. And now again, see, positive half cycle has been completed, and now negative half cycle of the supply voltage is appeared, and because of which the polarities across the midpoint cycloconverter will be now negative, positive, negative, positive. And now during this negative half cycle, I need to obtain positive half cycle of the output voltage to be controlled. So at this instant, now I need to provide the triggering pulse for the thyristor 3. only thyristor 3 has got scope such that thyristor 3 controls the current flow through the load from A to B, is it not? So that is how my positive half cycle of the output voltage will be controlled. And at this instant called T4, I need to forcibly commutate this T3 such that I'll trigger thyristor 2 so that I'll get negative half cycle of the output voltage control. And for which, during the negative half cycle, again, I need to provide the triggering pulse for the thyristor 2 such that thyristor 2 conducts current flow through the load from B to A so that I can control negative half cycle of the output voltage control. And the cycle repeats. So this is how we are getting for one cycle of input voltage, we are getting 4 cycles of the output voltage, and hence this is midpoint step-up cyclo converter operation. And now let us see step-down cyclo converter operation, and even this is midpoint type. Midpoint step-down cyclo converter, and for which, see, for 4 cycles of input voltage, I am obtaining 1 cycle of output voltage control. If you see here, let me indicate so that you'll understand. And here this is 1 cycle of input, 2 cycles, 3 cycles, and 4 cycles. And for 4 cycles of input voltage, I am getting 1 cycle of output voltage. That means here F0 is less when compared to that of the supply frequency. As we all know, frequency is 1 by time period, where output time period is equal to 4 times of that of the input time period. And here I am substituting T0 is equal to 4 times supply time period, and here 1 by 4 in the sense, 1 by T in the sense F is by 4. So output frequency is supply frequency by 4. That means our output frequency is less when compared to that of the supply frequency. And in order to obtain such kind of the output, we need to trigger the thyristors accordingly and obtain the required output. And during the positive half cycle of the supply voltage, this is the supply voltage, and during the positive half cycle, polarities will be positive, negative, and during this positive, negative. And in order to obtain positive half cycle of the output voltage to be controlled, in that case, I need to provide the triggering pulse for the thyristor 1 such that thyristor conducts current through the load from this point called A to B. From A to B, and that is how my positive half cycle of the output voltage is controlled, and it is conducting from alpha to pi, and because of the inductive load, the thyristor 1 is even conducting beyond pi and it will be conducting as long as energy stored in the inductor is present. And the moment it reaches pi plus alpha, thyristor 1 is getting turned off, and at this instant called pi plus alpha, if you see, negative half cycle has been appeared, and because of which polarities will be negative, positive, negative, positive. And in order to obtain positive half cycle of the output voltage, I need to trigger thyristor 3 such that thyristor 3 conducts current through the load in this direction, that is from A to B. That is same direction as that of the first case, that is when T1 conducted. That is how we get positive half cycle of the output voltage control till 2 pi, and this particular thyristor 3 is still conducting beyond 2 pi because of the presence of the inductor, and it conducts as long as energy stored in the inductor is completely dissipated. And once it dissipated and energy stored across the inductor is 0, at that instant again during the positive half cycle, we again provide triggering pulse for the thyristor 1 such that thyristor 1 conducts current through the load from A to B. So what? Our positive half cycle of the output voltage is controlled, and it is conducting beyond 3 pi because of the presence of the inductor. And again, at this instant, see, here T1 conducted, here T3 conducted. Now we have provided the triggering pulse for T1, and again during the negative half cycle, we are supposed to provide triggering pulse for T3 such that we will get positive half cycle of the output voltage control. And now, during which if you see positive half cycle of the supply voltage is appeared, and now I want negative half cycles of the output voltage to be controlled, so that I'll get one complete cycle of the output. So here for the negative half cycle to be controlled, I need to provide the triggering pulse. See, this is positive half cycle of the supply voltage which is being appeared, positive, negative, and during which I need negative half cycle of the output voltage to be controlled. For that, I need to provide triggering pulse for T4 such that it conducts current flow through the load in the reverse direction to that of the previous case. So that is how current is flowing from B to A, and that is the only reason here negative half cycle of the output voltage is controlled. And this negative half cycle of the output voltage is obtained because of T4 which is being conducting. And at this moment, again negative spike is being appeared because of the presence of the inductor. And again during the negative half cycle of the supply voltage, when negative half cycle is appeared, negative, positive, in order to obtain negative half cycle of the output voltage to be controlled, I need to provide triggering pulse for thyristor 2 such that thyristor conducts current from B to A. That is, negative half cycle of the output voltage will be controlled now. And again, because of the positive half cycle, polarities will be positive, negative, and in order to control the negative half cycle of the output voltage, I am supposed to provide triggering pulse for T4 such that T4 conducts current through the load from B to A. Because it is conducting current flow in the reverse direction to that of the first case from B to A, that is the only reason here negative half cycle of the output voltage is controlled. And again, this is T4, this is T2. Again, I have provided triggering pulse for T4, and now this is T2. And this is how I got 4 positive half cycles and 4 negative half cycles, such that for the 4 cycles of input voltage, I have got 1 cycle of the output voltage control. That is the reason this is step down cyclo converter, where output frequency is less when compared to that of the supply frequency. Coming to the single phase to single phase bridge type cyclo converter, and this is a step down cyclo converter. Why am I calling it a step down cyclo converter? For the 4 cycles of input voltage, for the 4 cycles, let me indicate. See, this is 4 cycles of the 2 cycles. 1, 2, 3, 4. This is another cycle of the input voltage. For the 4 cycles of input voltage, I am getting 1 cycle of the output voltage controlled. That means here F0 is less when compared to that of Fs. So here our time period, output time period is equal to 4 times of that of the supply time period. That means, as we all know, F0 is equal to 1 by T0. That means F0 is equal to 1 by, instead of T0, I am substituting 4 times of that of supply frequency. In that case, we get F0 is equal to, if T goes up, this will become Fs by 4. F0 is equal to Fs by 4. That in that case, what it is, F0 is less when compared to that of supply frequency. Hence, this is step down cyclo converter. So here, during the positive half cycle, this is positive half cycle of the input voltage. So the polarities will be positive, negative, and in order to control the positive half of the output voltage. Why I need to only control positive half cycle of the output voltage? It is because for now, in order to obtain 4 cycles of the positive output voltage to be controlled, I need to trigger only thyristors which conducts current flow from A to B, such that 4 positive half cycles of the output voltage can be obtained. That is the only reason. So this is the input voltage, positive, negative, and during which there is a scope for T1 and T2 to conduct. These two are forward bias. The moment when we provide the triggering pulse, T1 and T2 starts conducting current through the load, and that is how we are getting the output voltage waveform from alpha to pi. And this is due to the thyristor 1 and thyristor 2. And the moment it reaches pi, what happens? Supply voltage is 0, and it remains 0 until and unless we provide the next triggering pulse. So during the negative half cycle, the polarities will be now negative and positive, and because of such polarities, here T3 and T4 will be forward bias, and T4 starts conducting current through the load and back to supply. And if you see, in both the cases, current is flowing from A to B itself, downwards direction. That is how we are getting positive half cycle of the output voltage control. And it becomes 0 at this instant. And now here T3 and T4 conducted, and it remains 0 for this period. And again at this instant during the positive half cycle, we will have to provide triggering pulse for T1, T2. And again during the negative half cycle, we will have to provide the triggering pulse for T3, T4. That is how we are getting 4 positive half cycles control. And now, in order to obtain the negative half cycle of the output voltage, for that purpose, here during the positive half cycle, polarities will be positive, negative. So, since this is positive, T1 will be forward bias as well as T2 will be forward bias. So here T1 starts conducting current through the load. So if you see, current is flowing in the reverse direction because here T1 is conducting current from B to A. So current is flowing in the reverse direction to that of the first case. So that is how here negative half cycle of the output voltage is controlled, and this is due to T1 and T2. And during negative half cycle, the polarities again it will transform into negative and positive, and because of these polarities, T3 will be forward biased as well as T4 will be forward biased. So what T3 is conducting current through the load, and again T4 and back to supply. T3, T4, since it is conducting and it is conducting current through the load from B to A, and that is how we are getting the negative half cycle of the output voltage control. So this is T3, T4 conducting here. Again during the positive half cycle, we will provide the triggering pulse for T1 and T2 such that negative half cycle of the output voltage will be controlled. Let me show you this as well. So during the negative half cycle, yes, during the positive half cycle, we provide the triggering pulse for T1, T1 and T2. So that is how T1, T2 is conducting. So T1, hold, T2 and back to supply. And it is conducting current flow in this direction. So here T3, T4 is conducting. T1, T2 and again T3, T4 will be conducting. So if you see, for 4 cycles of input voltage, we are getting 1 cycle of output voltage control. Hence, this is a step down cyclo converter. And in the coming up lecture, we'll be discussing choppers. Thank you.